is we factor everything and we find out what the LCD is, the least common denominator. I can't really factor anything or cancel anything out, so I'm going to leave that one the way it is. The second fraction, though, I can definitely factor this. So I'm basically trying to figure out what two numbers will multiply to negative 12, but at the same time add up to a 1. All right. So 4 and 3. But since I'm multiplying to a negative 12, one of these has to be negative. So really the adding number, the positive 1 over here, is going to be the deciding thing. And to add up to a positive 1, then the 3 has to be negative. Okay, so the first fraction stays the same. It's not going to change yet. And the next fraction is going to be the same on the top, but the denominator can be factored as x plus 4, x minus 3. And then this fraction stays the same for now. Okay, so what is my least common denominator going to be? Well, the first fraction has an x plus 4. The fraction over here has an x minus 3, but the fraction in the middle has them both. So we're pretty much going to put both of the factors on all of these fractions. Okay, so the first fraction, it is missing the x minus 3. So I have to multiply the top and the bottom by x minus 3 to make it work. So I have x over x plus 4, and I'm going to put x minus 3 on the top and the bottom. Over here, for the next fraction, I'm going to keep that the same, since the denominator is already where I want it to be. So this is still going to be x plus 4 and x minus 3. For the next fraction, I've got an x minus 3 at the bottom. It's missing an x plus 4, right? So I've got to multiply the top and the bottom by x plus 4. Okay, there we go. So now all the fractions have the same denominator. That's good. So they have that common denominator. Next, what I can do is I can lift off the numerators since all the denominators are the same now. And I'm going to get x times x minus 3 minus 28 equals 1 times x plus 4. And we'll go from there. So now the denominators don't matter. All that matters now are the numerators, the tops of the fractions. So what I'm going to do is I'm going to distribute the x to everything inside the parentheses. I'm going to keep the minus 28 the same right here. And then over here, I'm going to multiply everything on the inside by 1. So everything should stay the same over here. So I get x squared minus 3x. That's if I distribute the x to everything on the inside, and the minus 28 is going to come down. Notice that I can probably factor this. We'll get to that later. Over here, 1 times everything will just leave an x plus 4. Okay. So now I'm at the point where I can probably get everything on the same side. That would help out a lot. So the x plus 4 over here, I can subtract x from both sides. Let's do that. Whoa. Subtract x from both sides. So I put the x terms with the x terms, and I can subtract 4 from both sides. That'll get rid of the positive 4. Okay, so what I've just done is I've made the right side equal to 0 because everything is going to cancel out over here. Now everything is going to show up on the left side. So the x squared is going to come down. It doesn't combine with any x squared terms, right? I'm going to get minus 4x minus 32. Okay, so do you see the quadratic equation that I've just made? Can we factor the left side? Go ahead and try that. We're going to be multiplying to negative 32, but at the same time adding up to negative 4. So what two numbers multiply to 32? Maybe 16 and 2, but that's not going to add up to a 4. I'm going to try some kind of 8 and some kind of 4. Now, since I'm multiplying to negative 32, one of these numbers does have to be negative. Is it going to be the 8 or is it going to be the 4? It's going to be the 8. Because I've got to add up to this negative 4 somehow, so the biggest number has to be negative. Makes sense, right? So I'm going to factor this as x minus 8 and x plus 4. Okay. So now that I've factored it, both of them are set equal to 0. So I'm going to get two different equations. I'm going to have this part equal to 0 and this part equal to 0. So let's set them up. I'm going to have x minus 8 equals 0 and x plus 4 equals 0. So now we can solve both of these for x. I can add 8 on both sides. Add 8 on both sides. I get x equals positive 8. Over here, I can subtract 4 from both sides. And I'm going to get negative 4. So my two solutions are going to be 8 and negative 4. Good. Okay, so it looks like I'm going to have two solutions for this equation, but let's go ahead and do a quick check of them. For the 8, if I plug in x is 8 for every single fraction, do I end up dividing by 0 anywhere? No. Because if I plug in x is 8 at the top, I'm going to get 8 plus 4 in the denominator. That's not going to give me 0. Over here, I've got 8 minus 3. If you look at that, I'm not really dividing by 0 anywhere, so I don't need to worry about this one over here. And the fraction in the middle, look at that. If I let x be 8, then I'm not really dividing by 0. So the 8 is actually going to work here. So the 8 is fine. What about the negative 4? If I plug in negative 4, do you see the problem up here? Let me change to a red pen. If I plug in negative 4 right here, do you see how I would be dividing by 0 at that point? Because really, I would have negative 4 plus 4 at the bottom, right? And then that would be dividing by 0. So I can't have that. Negative 4 is not going to work in my solution set. So I'm going to get rid of it. Negative 4 is what we call an extraneous solution. And if you remember that from radical equations, that means that negative 4 does not work in the context of this equation. So really, the only number that should be in my solution set is going to be 8. And that's it. -4 does not belong in there because I end up dividing by 0. Now, what I really want to do is I want to show you how extraneous solutions work when we graph it. So I'm going to give you guys a minute to finish copying this down, and then we're all going to go on to Desmos and see what it looks like when we graph it. Okay? So -4 definitely does not belong in the solution set. And I'm going to show you what happens when we plug in -4 when we're graphing. All right. So I'm going to go ahead and share my Desmos graph. And what I'm going to do is I'm going to graph both sides of the equation. Okay. If you can't see my Desmos graph, somebody send me a chat, but I'm just going to go ahead and graph both sides. So let's let the left side of the equation be f of x. So I'm going to have f of x is x over x plus 4. So x over x plus 4. And then I'm going to be subtracting 28 over x squared plus x minus 12. So what's that going to look like? It's going to look like 28 at the top divided by x squared plus x minus what? 12. All right, so that's going to be the blue graph that you see right here. And what you'll notice about the blue graph is it kind of is broken up into two parts. There's the part over here, that's the left part, and the part over here, that's the right part. Now, the right side of the equation is going to be 1 over x minus 3. So that's going to be my g of x. And I'll show you what this looks like when we're done graphing. Okay. And I'm going to change this to the color red because I kind of like red and blue. There we go. So now what you'll notice about the graph is it only crosses at one point. So where do the two graphs cross? Let me get rid of this. Let me come on over here. They cross right here at 8. So 8 really does belong in the solution set. But what about -4? We said that was extraneous, right? So does that really belong in the solution set? No, and I'll show you why. If we go over here to x is -4, see how we have -4 right here and -4 right here. Do the graphs cross at -4? No, they don't really cross at -4. So -4 is really what we call extraneous. It's one of the solutions that we got when we solved the equation, but when we checked it, we realized that -4 doesn't really belong in the solution set at all. And even if we zoom out, like I'm doing right here, we notice that the graphs don't cross anywhere else. They really only cross at one point, which is x equals 8. So I thought that was interesting, and I hope you do too. That's really the only point where the graphs cross, right? So I can't really justify the -4 being in the solution set. Okay. Am I back at my screen? Yes. Okay. So I'll leave this up there for about a minute longer so you guys can get it, and we'll move on to the last one that we're going to talk about today.